Pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today we are going to discuss about the machine translations with the encoder and decoder architecture. The encoder and the decoder model is a way of using a recurrent neural network for a sequence to sequence prediction problem. It was initially developed for the machine translation problem, although it has a proven successful at the related sequence to sequence prediction problems such as text summarization and the question answering. The approach involves two recurrent neural networks, one to encode the input sequence called as encoder and the second to decode the encoded input sequence into a target sequence called as decoder. We have various basic sequence to sequence model like chatbot, machine translation, text summary and the image captions. Prior knowledge is all about the basic architecture of encoder and decoder. The overall structure of a sequence to sequence model, which is commonly used to know, is all about. It consists of three parts: encoder, intermediate vector, and the decoder. The encoder is all about it accepts a single elements of the input sequence at each time step, process it, collects the information for that element and propagate it forward. And we have an intermediate vector. This is a final internal state produced from the encoder part of the model. It contains information about the entire input sequence to help the decoder make an accurate predictions. And the basic understandings of the decoder of the model is all about the encoder is basically LSTM or GRU cell. An encoder takes the input sequence and can encapsulates information as an internal state vector. The output of the encoders are rejected and only the internal states are used. The basic models of the encoder is all about the LSTM takes only one element at a time, so the input sequence is of length. The LSTM takes m time steps to read the entire sequence. The XT is the input at the time step t. HT and CT are the internal states at the time steps t of the LSTM, and for the GRU there is only one internal states HT. YT is output at the time step t. The basic input from the encoders of XT is the XT is a LSTM which uses a sequence by word in a 4 steps of following. It learns from the LSTM which has read until the time steps t. The initial steps H0 is initialized randomly with the zeros. Remembering the dimensions of H0, C0 is the same as the number of units in LSTM cell. The final states of H4, C4 contains a clues of the entire input sequence. India is a beautiful country, which states that with representations of LSTM. The output of the encoders, which is all about YT, is at each step in these predictions of the LSTM at that step. The machine translation problem, which generates output which have read the entire input sequence, so that the YT at each time step in the encoder is of no use when we have discarded. So the encoder which reads any of the English sentence word by word by stores the final internal states of the LSTM generates after a long time step, since output will be generated once the entire sequence is read. Therefore, the output y of t is encoded at each time steps or discarded. Hence, we can also state the decoder as a process. The decoder is all about giving the entire sentence. It predicts an output at each time steps. The working of the decoder is different from the training and testing the phases until the encoded part of the model, which works in the same fashions in training and test phases. Let us first understand the working of the decoder part during the training phase, taking a running examples of translating India as a beautiful country to its Hindi counterpart. Just like an encoder, the decoder also generates output sentence word by word. For the decoder to recognize the starting and the ending of the sequence, we will start at the beginning of the output sequence and end at the end of the output sequence. The initial state, H0 of the decoder, is to set the final states of the encoder. It can be thought as that of the encoder is trying to generate the output based on the information gathered by the encoder. First we input the start so that the decoder starts generating the next word. After the last word in the sentence, we make the decoder learns to predict the end. So hence we summarize the initial states of the decoder or of two final states of the encoder. The LSTM's decoder process single words at every single step. The input to the decoder always starts with the start. The internal state generates after every time steps as speed as the initial states of the next input step. For example, t is equal to 1. The internal states produced after inputting start is feed as initial steps state as t is equal to 2. The output produced at each time step is feed as an input in the next step. We need to know at the end of the sequence why the decoder predicts the end. So hence we also trained by using the various steps like pre-processing. After the pre-processing, adding a starting and the ending to the Hindi sentence, creating the vocabulary of all the unique English and Hindi words, compute the vocabulary size and the length of the maximized sentence of both English and Hindi languages. Next, we can also create Python dictionaries to convert the given words into an integer index and the vice versa. We can also split the data into train and the text and define the functions which generates the data for training and the testers in batches. The next step is to define the encoder and the decoder architectures. So hence we refer that the encoder and the decoder networks or the sequence network or model capable of generating a contextual appropriate arbitrary length output sequence. Encoder and the decoder network are applied to a wide range of applications including a machine translation, summarizing the question, answering and dialogues. The key idea is underlying these networks is the use of the encoder network that takes an input sequence and generates a computational or contextual representation of it, often called as a context. The representation is then passed to the decoder which generates a task-specific output sequence. The encoder and the decoder network consist of three components where the encoder that accepts the input sequence and generates a corresponding sequence of a contextual representation. The LSTM convolutional network and the transformer can also be deployed as an encoder. And we have an encoder and decoder with the RNN. Where the RNN and the encoder and decoder paired with the number of RNN and recalling each and every phases of these steps. Hence we conclude that the encoder and decoder architectures are achieved in a remarkable achievements of the machine learning process, and where we can convert all these things in a better sense with a translation accuracy and the fluency. I hope you are clear with this concept. Thank you.